to cover everything we need to cover, and I'm going to give you the rest of the period to go ahead and get it done during class, so you're not behind. I do want to say, doing the matrix unit here, I like that because what I see every year during the matrix unit is I see a lot of kids raise their score in the class, raise your grade, because the matrices are pretty simple. You can go back and redo them as many times you want to till you get that 4 out of 4, and then screenshot it. If you're confused, the video is right there. You can go back and rewatch the video or look at the lesson again. Anytime you miss one, it can explain exactly what you got wrong on it. So it's real easy to go back and understand the matrices with as much help as given on the website and through the practice we do. And the fact that you can redo it 100 times if you want to get a good score. And I have a lot of students that just start maxing out 100% all the way through the matrix unit, and helps their overall semester grade. And so I like the matrix unit for that fact that I see a lot of students really use it to their advantage, that you can make sure you turn in a 4 out of 4 every time. Oh, you get a 4. I'm going to redo it. Oh, got it. Super. So that's good. Also, I've been talking about this week. We have a lot of issues these days throughout our society with people not feeling very good about themselves. They don't have much self-confidence, or don't feel like they're not worth anything. Self-worth, we're anxious. That's a big issue, more than I've seen in my life nowadays. And a lot of people don't know where to go with that, and they don't know what to do with that. And they think that they need someone's approval. We don't get self-worth from other people. We really don't. People will say, "Oh, you're a great person, man. I love you. You're fabulous. You're good." Still, we're like, yeah, okay. We don't believe it because we've convinced ourselves, I'm not that good of a person. I'm not that smart. I'm not whatever. And I see that, my wife still doesn't think she's as smart as she is. And man, she teaches chemistry. She's a whiz. She had a higher GPA in high school than I did. And she's bright. She's a bright woman, but she grew up with a stepdad who told her she was trash, and still believes that. And it's hard to get that self-worth up there. The way we get self-worth, self-confident, and feel better about ourselves is we have to do things that we respect. We have to do things that we admire. And as we experience and see ourselves do things that we admire, we start to admire ourselves because we see the things we're doing. We start to respect ourselves because we see the things we're doing. We build integrity. We build character in ourselves because we do the things that we admire and respect and see people of integrity do. So we don't get it from other people. We get it from ourselves. And saying that, last week, I had a lot of students turning in late work, emailing me with questions, email me to say, hey, I got this done. Can you go back and check it? All kinds of stuff. When we didn't have school last week. We had a lot of snow, didn't have a lot of school, which is great. It's nice to have that break. Teachers, we still worked every day, but you guys didn't. And so I had students that were saying, man, I'm behind in this class and that class and that class. I'm going to use this time. I'm going to get caught up on that. And so now you get to this week. They turned in all this late work last week. You guys, I'm proud of you, but I know you're proud of yourself because those are the type of things that make you feel better about yourself, that make you admire yourself more, that I made a good use of my time and I got caught up on this stuff I was behind. And now I got a fresh start. Here we are almost to March. This weekend is March, and I'm in a good position this semester. That's awesome. And I'm so happy for you. I'm glad you got to that point because a lot of you folks did that. And there's a lot less missing assignments this week than there was the Friday before last, the last day we were in school. So just wanted to stop and make a point to let you guys know that I noticed because I saw it in all of my classes. I saw work getting turned in last week. And I mean, we can only play in the snow so long until we got to warm up, right? So, hey, a lot of you guys use that warm up time to get stuff done and get it off your plate to where you can just enjoy life and go, great, I don't have all this hanging over my head that I got to do. So That's why I want to get things done today. Give you time to get the lesson done today so you're still current, right? So let's jump into it. Let's see what we have to look at today with matrices. Okay, this is fifth period. Am I caught up on my work? I got caught up on work last week. I got in a lot of classes I was behind on. Let's see. We should be done with week 24, the first quiz in matrices. Week 25, actually, the folder has a lot of stuff in it, but I have kind of moved the due dates around. So we're only going to do the first folder, adding and subtracting matrices. We've pushed this one off another week. So don't worry about the second folder in the week 25. If you want to go ahead and work ahead, that's fine. I don't have a problem with that. That's kind of why I put this out there. You can go all the way and do the matrix quiz too if you want to and be done with matrices. Just make sure you review the videos and lessons so you know what you're doing. You don't want to bomb it and lower your grade, but it's there for you to work ahead if you want to. That's always an option. But we're going to just do the adding and subtracting matrices week 25 assignment. Let me go to the activities. Closing week 24. It's finished. We are on week 25. And like I said, we're only doing the first folder. This one we'll save for next week. So let me open this folder. We have a video, we have a lesson, and then we have the two assignments. So let's take a look and see what this is going to have. And as soon as it opens up, we'll get that going and see what we're learning about matrix addition and subtraction this week. All right, 5 minutes, 35 seconds.
Let's think about how we can define matrix addition. And mathematicians could have chosen any of an arbitrary number of ways to define addition, but they've picked a way to define addition that seems, one, to make sense, and it also has nice properties that allow us to do interesting things with matrices later on. So if you were one of these mathematicians who are first defining how matrices should be added, how would you define adding this first matrix over here to the second one? Well, the most common sense thing that might have jumped out at you, especially because these two matrices have the same dimensions. This is a 2 by 3 matrix, has 2 rows and 3 columns. This is also a 2 by 3 matrix, 2 rows and 3 columns, is to just add the corresponding entries. And if that was your intuition, then you had the same intuition as the mathematical mainstream, that the addition of matrices should literally just be adding the corresponding entries. So in this situation, we add 1 plus 5 to get the corresponding entry in the sum, which is 6. You can add -7 plus 0 to get -7. You can add 5 plus 3 to get 8. You can add, and I'm running out of colors here, you could add 0 plus 11 to get 11. You can add 3 to -1 to get 2. And you could add -10 plus 7 to get -3. And if you see this definition of matrix addition, you see that it actually does not matter in what order that we actually add these matrices. I could have done this the other way around. If I did this the other way around, let me copy and paste this. So if I were to add this matrix, so let me copy and let me paste it. If I were to add it this way, that matrix to, let me copy and paste the other one, to this matrix. So copy and paste. If I were to go this way, you'll see that the order in which I'm adding the matrices does not matter. So this is just like adding numbers. A plus B is the same thing as B plus A. What we'll see is that this won't be true for every matrix operation that we study. In particular, this will not be true for matrix multiplication. But if you add these two things, using the definition we just came up with, adding corresponding terms, you'll get the exact same result. Up here we added 1 plus 5 and we got 6. Here we'll add 5 plus 1 and we'll get 6. We get the same result because 1 plus 5 is the same thing as 5 plus 1. Here we add 0 plus -7, you get -7. So you're going to get the exact same thing as we got up here. So when you're adding matrices, if you were to call this matrix right over here matrix A, which we normally denote with a capital bolded letter, and you call this matrix right over here matrix B, then we take the sum of A plus B, which is this thing right over here, and we see it's the exact same thing as matrix B plus matrix A. Now let me ask you an interesting question. What if I wanted to subtract matrices? So let's once again think about matrices that have the same dimensions. So let's say I'm going to have two 2 by 2 matrices. So let's say it's 0, 1, 3, 2. And from that, I want to subtract -1, -1, 3, 0, and 5. So you might say, well, maybe we just subtract corresponding entries. And that indeed is how you can define matrix subtraction. In fact, you don't even have to define matrix subtraction. You can let this fall out of what we did with scalar multiplication and matrix addition. We could view this as the exact same thing as taking 0, 1, 3, 2, and to that we add -1, -1 times -1, 3, 0, 5. And if you work out the math, you're going to get the exact same result as just subtracting the corresponding terms. So this is going to be, what is this going to be? 0 minus -1 is +1. 1 minus 3 is -2. 3 minus 0 is 3. 2 minus 5 is -3. And you'll see that you get the exact same thing over here. When you multiply -1 times a -1, you get a +1. +1 plus 0 is 1. -1 times 3 is -3, plus 1 is -2. Fair enough. There might be a question that is lingering in your brain now. Okay, Sal, I understand. When I'm adding or subtracting matrices with the same dimensions, I just add or subtract the corresponding terms. But what happens when I have matrices with different dimensions? So, for example, what about the scenario where I want to add the matrix 1, 0, 3, 5, 0, 1 to the matrix, so this is a 3 by 2 matrix, and I want to add it to, let's say, a 2 by 2 matrix, 5, 7, -1, 0. What would we define this as? Well, it turns out that the mathematical mainstream does not define this. This is undefined. This is undefined. So we do not define matrix addition or matrix subtraction when the matrices have different dimensions. There didn't seem to be any reasonable way to do this that would actually be useful and logically consistent in some nice way.
All right, there you have it. We got the overview of how addition and subtraction works, and it's really very simple, right? We just add and subtract the first row, first column to the first row, first column, and that gives us the answer in the first row, first column, and so on and so forth. So let's get back to looking at the lesson and see what the assignment goes with this. So that was the adding and subtracting matrices video. If we go back, let's look at the lesson that goes with it. And it basically is the same thing. It just covers it where we have some practice problems to make sure we understand how this all works. So let's go back to Khan Academy. And remember, when you're at Khan Academy, make sure you're logged in with your school login up here. It'll keep track of what you do. So if you don't screenshot something, you forget something, you can go back and it'll remember it for you. See, like I've already worked this assignment, add, subtract matrices. It remembers that because I'm logged in. If you're not logged in, you'd have to redo it all every time. But you can close this little half tab, right? This just reviews again what a matrix is. This is a 2 by 3, 2 rows, 3 columns. So it reminds us that every time, just so we don't forget how matrices work. And here's the adding matrices part. Here's the lesson that he just covered in the video also. So if we have matrix A, which is 4, 8, 3, 7, and matrix B, 1, 0, 5, 2, let's find A plus B. And these are capital bolded to tell you they're talking about matrix A and matrix B added together. So we simply add the corresponding entries. That means the ones that are in the same position. The first row, first column 4 is added to the first row, first column 1. 4 plus 1, which gives us the first row, first column 5. 4 plus 1. 8 plus 0, 3 plus 5, 7 plus 2. So we're really going back to like our first grade math right here. We just have it organized in a matrix. Instead of giving you a list of problems that say 4 plus 1, 8 plus 0, 3 plus 5, I'm just giving you a matrix. So let's see if we can do this. I'm going to open up the chat so you guys can fill in some blanks for me. What is the top row of the A plus B answer going to be for this matrix? Just to make sure we're all on board, we understand how this works. What am I going to put in the top row when I add A plus B? 2 and 5? Anyone else agree with that? Oh, yeah, I was like 78. Wait, okay, yeah, 7. That's better. All right. Yeah, no, that's better, Madison. Anyone else? Madison's already answered and corrected herself. She still got frozen snow fingers. They're trying to type there. That's good. Yeah, we take the first row, first column 5, add it to the first row, first column 2, and we get a 7. First row, second column 2, first row, second column 3, 2 plus 3 is 5. All right, how about the second row here? We've got a 0, 1 in matrix A. We've got a 4, 1 in matrix B. You guys are on that pretty quick. 0 plus 4. Oh, that's great, doing first grade math again. 1 plus 1. It doesn't get much more first grade than 1 plus 1. 2. All right, last row of our matrix. We've got a 1, 9 in matrix A. We've got a 0, 2 in matrix B. Let's see if we can add 1 plus 0. Madison's already on top of it. 9 plus 2. Hey, we've gotten the double digits. That may be second grade. I don't know when you learned all that. Let's check. Green check mark. We did good. Fabulous. All right, let's look at another one. Now, this was a little different. Here they gave us A, B, and said, what's A plus B? This, they just give us two matrices. We don't name them A and B this time. We just said matrix 10, negative 10, 12, negative 6, 3 is added to matrix negative 1, 4, 22, 7. So what numbers are we putting in the answers over here? Trying to get tricky on you. We're throwing negative numbers in there. That may be second grade. Negative 10 plus a negative 1. Madison's on top of it. Negative 11. 12 plus 4, 16. So we got a negative 11 and a 16. All right, then bottom row, we got a negative 6 and a positive 22. And we have a positive 3 and a positive 7. So 16, 10. Good job. All right. Let's talk about subtracting. Not much more difficult than adding. In fact, it shouldn't be any more difficult for high schoolers, right? C is this matrix 2809. D is this matrix 5, 6, 11, 3. If we take C minus D, we simply subtract the corresponding entries. 2 minus 5, negative 3. 8 minus 6, 2. 0 minus 11, negative 11. 9 minus 3, 6. All right, the only place that we generally mess up on this is we forget a negative, or we forget we're subtracting, we add them instead. So the only tricky part about this is just paying attention to the details, right? Making sure we know what we're doing. All right, so we've got X and we got Y, and we're subtracting X minus Y. So give me the top row. Ruben's got it, man. He's in 4 minus 1. 16 minus 15. All right, how about the next row? This wasn't too bad. We didn't have any negative numbers we had to work with on this one, right? 10 minus 6. 22 minus 3. All right. Thank you much. Good to go. All right, here's another one. This one's a little different. It's a 3 by 3. 3 by 3. Now remember, first thing we really do is check, can you add or subtract? If they're not the same size, it's undefined. There's no answer. These are both the same size, so we do have an answer. The answer should also be a 3 by 3. So the top row of our 3 by 3 is it a 2, 2, 2? Wow, is that right? Is it 2, 2, 2? You want to double check that? Oh, wait. Madison's wait. It says this should be a negative 2. Like I said, when we mess these things up, that's usually what we do. We forget a negative somewhere. Yeah, we've got 4 minus 6. So yeah, the middle one is a negative 2. 3 minus 1, 9 minus 7, but that middle one is a negative number. Good catch. Good catch. How about the second one? 686 minus 642. What are they doing to it this time? No negatives here, huh? 0, 4, 4. Yeah, that's 6 minus 6, 8 minus 4, 6 minus 2. How about the last one? They're going to throw a negative in that one. They're going to try to trip us up. We got a 734 and a 415. 3, 2, negative 1. So we had a couple of negatives in there. Let's check it out. All right, that's good. And it did want to make the point of scalar multiplication is the same as repeated addition. Like if we have this matrix A and it's 4, 8, 2, 1, and we want to find A plus A plus A, we can take the same matrix 3 times, 4, 8, 2, 1 plus 4, 8, 2, 1 plus 4, 8, 2, 1. And we know how addition works. We take the 4 plus the 4 plus the 4, and then the 8 plus the 8 plus the 8, and the 2 plus the 2 plus the 2 plus the 1 plus 1. But we also learned in elementary school, maybe by second grade, that instead of doing 4 plus 4 plus 4, we can just do 3 times 4, because that's the same thing. 3 times 4 is the same as 4 plus 4 plus 4. And 3 times 8, and 3 times 2, and 3 times 1. So it's just 3 times 4, 8, 2, 1, or 3 times matrix A. So A plus A plus A equals 3 times A. That makes perfect sense to us because we learned this 10 years ago when we were in elementary school, how adding the same number multiple times is the same thing as multiplying it. And subtraction is the same as adding the opposite. If we have A minus B, we could just make negative B and add it to A, right? 2 plus 3 is 5. If we were to subtract 5 minus 3, we can either subtract 3 from 5 or we can add a negative 3 to 5 and go back to 2. Okay, that's all the lesson. Now we have the actual 2 assignments that we have this week. Add and subtract matrices, and then matrix equations, addition and subtraction, which are a little different than this first one. And I'll tell you, yesterday this wasn't working, so we'll see how it does today. Add, subtract matrices assignment. When we go to this, remember on this assignment, this is where we go down and we screenshot and paste our score. So this is where I said you can do it over and over again before you ever screenshot. Don't screenshot if you get a 1 out of 4. And I will say nobody has turned in a 1 out of 4, so good job. But get 4 out of 4. Make sure your name's up here. Go ahead and close this extra little tab. Don't care about that. Ready to practice. Show us what you can do. All right, let's go. Add and subtract. So the first thing we do is check to see what they want us to do. Add or subtract. Because if you don't pay attention, you're going to end up adding one that was a subtraction or subtracting one that was an add. Check that first. Then the next thing we check is, okay, it wants us to add. Are these the same size? And they are. They're both 2 by 2 matrices. So it should have a 2 by 2 answer. And we should just add them together. 3 plus 4. 1 plus 0. 1 plus 0. This is really elementary school math. 0 plus 3. Negative 2 plus negative 1. That gets a little tricky. It's a negative. Negative 2 plus a negative 1. Negative 3. See how we're doing? Yay. Next question. This is a little different way of showing it. Find the values of X and Y in this matrix addition problem. So you see it's a plus. They're adding this matrix to this matrix, and they have this answer. Where is the X? The X is right down here. What is the value of X? X is being added to negative 2, and it equals 2. So what plus negative 2 equals 2? Well, X would be 4, right? 4 plus negative 2 equals 2. How about y? Y is right up here. 2 plus y equals 0. 2 plus y equals 0. So y must be negative 2, right? 2 plus negative 2. Yay, next. Find the difference. If you're reading, you got to think right away, oh, this is not addition because difference is subtraction. This is where we have to be careful because we're going to mess it up because we don't pay attention to those negative numbers. -1 minus 1. Your instinct might say -1 and 1, that's 0. No, that's only if you're adding. -1 minus 1 more is now -2. -2. 3 minus 4. -1. 4 minus 3. Well, there's the positive side. And 1 minus 0 is a 1. Let's check. All right. And, you can always click see how we answer this question. They'll show you how they worked it. -1 minus 1, 3 minus 4. So they'll help you if you need it. If you miss it, definitely see how they answered the question. All right, here are 4 matrices. I love this question. I'm going to look for it in the chat. This is our chat opportunity here. We have matrix A, matrix B, matrix C, and matrix D. I want to know which of these are possible and choose all answers that apply. So there may be more than one that's possible. Can we add A plus B? Can we subtract B minus A? Can we subtract C minus D? Can we add D plus C? Which of these are even possible to do? It's not asking for the answer. I don't care what adding them together equals. I want to know, am I even allowed to add any of them together or subtract? Madison says we can do all of those. She says we can do A, B, C, and D. Now, when I did this yesterday, there was only one of them I could do. So let's see, is this true? A plus B. Delilah agrees. Maybe that's right then. This is a 2 by 1, 2 rows, 1 column. This is a 2 by 1, 2 rows, 1 column. So, yeah, we should be able to add those together, and we should be able to subtract one from the other. Either way, A minus B or B minus A. Now look at C and D. C has 1 row and 2 columns. D has 1 row and 2 columns. They are the same. So, yeah, we can do anything with C and D. It is actually all of them. Wow, great job. That's not what I usually see. It's usually not all of them, but they did that. So here's our summary. Here's where we want to get our screenshots. 4 out of 4 correct. So I'm going to get my old screenshot here. There's my screenshot. Let's go back over here and paste. Paste. There it is. Mr. Brock, add and subtract matrices, 4 out of 4. Submit my work. Done with that assignment. Let's look at our second assignment. Matrix equation. And like I said yesterday, this one was giving us some trouble. So if it doesn't work, we'll talk about that. Matrix, addition and subtraction, matrix equations assignment. If you get here, what was going on yesterday is we'd have a 2 by 2 and a 2 by 2, and it would say add these together. And the answer, the boxes they gave us from the answer would be like a 2 by 3 or a 3 by 2. It would have extra boxes. It's like, wait, if I have a 2 by 2 adding to a 2 by 2, I should just have a 2 by 2 answer. So when it gave me like a 3 by 2, I'd put in the 2 by 2 and then leave the others blank, and it would say, oh, you're wrong, try again. And so then I put X's in those, like, okay, maybe these need X's because I've not used them. You're wrong, try again. Let me put capital X's. Wrong, try again. And it just kept doing it. Oh, it would never tell me the answer. It would never let me go skip and go to the next one. It's like there's no way to get this right because I put in the answer, but it gave me extra blanks, and it's not telling me what to do if I have extra blanks because we shouldn't use extra blanks. If it does that to you, just take a screenshot of that page and turn that in, and I'll give you full credit because if it's messing up, there's no way to do the assignment. Now, if it does it right, like this first problem I'm looking at, we're about to look at, it looks like it's fine, and we'll be able to do it. But if you run into one where the answer is not the right size, it won't let you do it, screenshot that, turn that in, and you're good to go. So I'm good with that. So let's take a look and see what this shows. What does it say I did last time? Oh, yeah, 75%, because I couldn't answer one of them. It wouldn't let me do anything. We have, this is a little different way. That's what I said. This assignment's a little different. This is a different way. Here's a matrix: 4, negative 21, 13, 6, 8, negative 9. Plus matrix X equals 7, negative 16, 12, 19, 1, 0. So it wants to know, what is matrix X? So we're having to fill in an entire matrix. If we're adding this matrix to matrix X, what does matrix X have to be for this to be the answer? See how that's a little different? So 4 plus something equals 7. Okay, that's a 3. Negative 21 plus something equals negative 16. Oh, so that'd be a positive 5, right? Because it's getting closer to 0. 13 plus something equals 12. Okay, negative 1. 6 plus something equals 19. So 6 plus 13. 8 plus something equals 1. 8 plus negative 7 equals 1. Negative 9 plus something equals 0. So negative 9 plus 9. So we should be able to hit check. Good work. Let's see if the next one's going to cooperate. Keep going. 2 out of 4. Oh, I was on the last problem, so I need to start it over. Try again. Bottom left corner, I can try again. Because that's what was giving me trouble yesterday, so I quit the assignment. All right, 2 by 2, 2 by 2. All right, so this one looks right. X plus negative 12 equals 2. So 14 plus negative 12 equals 2. Something plus 15 equals 8. Negative 7. Something plus 15 equals 1. Something plus 6 equals 3. So there's a lot of negatives in here. All right, next question. Here we go. This is the one that's, like I say, it's been messing up, and I don't know why. We're not going to get past this one. Something plus this equals this. So the top row, X plus 2 equals negative 13. So negative 15 plus 2. Something plus negative 2 equals 24. So that'd be 26 plus negative 2 is 24. Something plus 6 is 24. I'll try that this time, Braden. Maybe that'll work. Something plus negative 8 equals 24. So 32. Something plus 17 equals 13. And something plus 9 equals 12. So, all right. So first, let's just see if it'll let us leave those blank, because there shouldn't be anything in the third row because we don't have a third row. Not yet. Give it another try. Okay. Let's put zeros. Not yet. Give it another try. Let's just put like X's. Not yet. Give it another try. Capital X's. Oh, it's not letting me capital. Oh, there we go. Capital X's. Let's try capital X's. If I hit show a step, it just shows you how to do it. We can represent the matrix with letters. It will solve the equation. If I get another hint, it's just telling me how to work the problem, which I'm doing. Get another hint. And look, it's giving us the answer right there, but that's what we've got as an answer. It doesn't show that extra row that this has. There's not supposed to be another row. It'll get another hint. That's just the answer. So the hints aren't helping us at all because we've got that part. This is the part we don't know what to do with, and it's messing up. If I just put a space in there, let's just try a space. Not yet. Give it a try. Hints. Show solution and move on. It won't let me do that. See, it's not showing me, well, it's showing me a solution because there's a solution, but it's not letting me move on to the next problem. It's not counting this one right. It's something is malfunctioning on the website. There's nothing I can put in here and make it go on. So that's when I would get my screenshot, I'll go and say, there it is. I can see that there's an extra row there. And this is what I'm going to go in and turn in to see that it's malfunctioning. And when I submit that, I'll get 100%. I will give you full credit if you can't do it because the website is messing up. Right? The website's messing up. I don't want you to be penalized for that. I'll give you 100% on it. It actually, you get them all right automatically if it messes up on you, which I think is more fair than just excusing the assignment. If I excuse it, that misses 100% that could help you, right? Because this could help you. 100% could help you. If I just don't count it, then that brings your overall points down that you can get, and this doesn't help you at all, rather than getting 100%. So doing that to help. So that's covered everything I'm expecting this week, guys. We're going to leave the other folder of multiplying matrices by scalars. We're going to leave that for next week. We're going to make this an easy week. So if somebody, there are still some people that have missing assignments. Not everyone got everything turned in. A lot of you did, and I'm really happy about that. But there are some people that are missing some matrices assignments. So they can go and catch up. So I want to give you the rest of this class period to, well, get these 2 assignments done. Yay, I'll be done for the week. And if you're missing any of the other matrix assignments or assignments from earlier, use some time, go do that. So this is a B week on Friday. So that's actually good news because Thursday, I won't be here. Today is the ACT day for students on campus. If students can't come on campus, they're taking the ACT on Thursday in a different building, and I'm going to be the one that's there giving the ACT. So I won't be here because I'm giving the ACT on Thursday. So I won't hold class on Thursday, but we have Friday. So if you have questions, you can come Friday and get your questions answered and get this all up to speed. So I'll give you the rest of this period to work on that. I'll stay in class if anybody needs help, but otherwise you don't have to stay in class to work on this. Just get this turned in. Make this an easy week for you by getting it done early. And here it is, Tuesday morning. You'll be done with your algebra. So, but yeah, if you're behind, get caught up. But we'll see you guys. Have a great week. I'll see you maybe Thursday, maybe Friday, maybe next Tuesday.